Okay, Algebra 2 kids, this is section 8.4. Now, just a reminder, we skipped 8.1. 8.2 was on parabolas, a little different way to think about parabolas than what we did back in chapter 1 with quadratic equations. Here we're talking about parabolas with a focus and directrix. 8.3 was on circles that are centered at the origin. By the way, the parabola's vertex was also at the origin from 8.2. Today we're talking about ellipses that are centered at the origin as well. An ellipse is kind of like a flattened circle, kind of for better, or for lack of a better definition. If we look here, I added some notes to your typical study guide here. This first page of notes, these are snippets out of your textbook that I thought were good, so I added these to the notes. 8.4 ellipse says an ellipse is the set of all points P in a plane such that the sum of the distances between P and two fixed points called the foci is a constant. So now we had a focus when we talked parabola. In an ellipse, we've got two focuses, and the plural of focus is foci. So we've got two foci here. You can tell in this ellipse, okay, this one right here, I hope you can see me kind of tracing over it. Okay, so in this ellipse, all of the point P's around the ellipse have the exact same sum of the distance between the two foci. Okay, now I am going to show you a GIF. Or GIF, depending on how you pronounce it. My son assures me it's GIF. So I'm going to show you a GIF that is a little animation on how we get ellipses, why they have the shape they do. Okay, so let me see if this works for us. Here we go. So here's what it looks like. If we had a string, okay, that was of set length, and it was tacked on the two foci points, okay, and we use this pencil, you can see it going around and around. That's how we create an ellipse. All the points around come from a set distance between the two foci. Okay, that string length between the two foci points does not change. So if we used a pencil and went around, okay, that's where we get an ellipse. Okay, I hope that helped. I liked that little GIF. Okay, so now, oh boy, what did I do? Going back, okay. So our ellipses then. We've got two lines kind of that go through the ellipse. Obviously, in this case, it's the X and Y axis. And we have vertices. Now, depending on which direction the ellipse is flatter, or maybe I should say longer, that is your vertex points, the end points there. So like on this first ellipse on the left here, this point and this point are your vertex points, okay, your vertices. That is where the ellipse is longer on the x-axis than it is on the y-axis. Okay, notice on the y-axis, these are called co-vertex points. Okay, so we have vertex points, and we have, those are on the long, what we call the major axis. Okay, and then we have co-vertex points, which are on the minor axis. Notice here, major axis, okay, again, vertex point, vertex point. So your length of your major axis is actually, length of a major axis is 2 times A, if A is one of your vertex coordinates. Okay, your minor axis, okay, is in this one your y-axis. That's where it's shorter, okay, your ellipse. and its length, okay, is going to be 2b, because notice b's are our coordinates for our vertex, co-vertex, sorry. A's are the coordinates for our vertex. Now, where do the foci come in? Okay, here's the foci. This point and this point are your focus points. Okay, and again, they've got coordinates with C and negative C. Okay, so we have vertices, we have co-vertices, and we have foci. Okay, vertices are on the major axis, the longer one. Co-vertices are on the minor axis, which is the shorter one, and your foci are the two set points that, like, if you think about that GIF in your mind, that's where, you know, that set length of string was tacked on each end. Okay, now that, as you can tell by the definition, is an ellipse with the horizontal major axis. This is the basic form of the equation of an ellipse. Okay, notice there's a plus in between, and notice that it equals 1. Okay, always. Now, notice here also that the a squared is under the x squared. Why is that? Because our x-axis is our major axis. That's why the a squared's under the x squared. Okay, over here on the right-hand side, if you look at this ellipse, notice it's longer vertically. Okay, so now our y-axis is our major axis. Okay, and so our y-axis being our major axis, that's going to be our a. And again, notice here our a squared is under the y squared, because our major axis is the y-axis. In this case, our minor axis is the x-axis. Okay, that's where it's shorter. And again, that's our b. That's where our b terms come in, our co-vertex. Okay, and notice again on our equation, our b squared is under our x squared. So whichever one is bigger, the a squared, okay, that is going to be your major axis. Whichever variable it's under, whether it's under x or y, that's going to be the major axis. So here on the left one, the a squared was under x squared, x was your major axis. Here on the right one, your a squared was under y squared, so y was your major axis. A is always going to be bigger than b, okay, in this case. And then again, your foci here, you've got foci with point C and negative C, okay? And here in just a minute, I'll show you how you get your C. It's actually an algebraic formula for C. But again, I want to point out the plus and the 1, okay? Ellipses have basic equations where you have x squared over a constant plus y squared over a constant equals 1. Okay, that's the basic form. Now, this, again, is another thing out of your textbook. And again, standard equation of ellipse with center at origin. Okay, just want to point out, if a squared is bigger, let me just say on all of these, a squared should be bigger than b squared. Okay, a squared should be bigger than b squared. Notice it says where a is greater than b is greater than 0. Okay, so if the a squared is under the x squared, then the major axis is horizontal. Your vertices are plus or minus a comma 0. Co-vertices, remember that's the shorter one from your minor axis. So remember this is major axis. This is minor axis, is where your co-vertices come in. Okay, and those are going to be on your y. Now the one below, again, notice your a squared now is under your y squared. So your major axis is going to be vertical instead of horizontal. Okay, so again, major axis, this one's going to be the y. That's why you have 0 plus or minus a, and your co-vertices is on your minor axis. That's going to be your x-axis in this one, so it's plus or minus b comma 0. Okay, and it says down here, this is a biggie. This is your formula for how you get your foci points. C squared equals a squared minus b squared. C squared equals a squared minus b squared. So if we go back up here, all of these focus points, okay, all of these focus points use this formula. C squared equals a squared minus b squared. That's how we find the focus, okay, in every instance. Okay, doesn't matter which one is the major axis, which one is the minor axis. All of these use the formula c squared equals a squared minus b squared. Okay, so that's where your focus coordinates come from. You just have to know that your focus is always on your major axis. Let me say that. Okay, it's a good point to make, I think. Your foci are always on your major axis, always. Okay. So in this case, I'm going to add a little bit to this chart here. If your vertices are plus or minus a0, I'm going to add over here a third column here, your foci. Whoops, I can't spell. Let me rewrite that. Your foci, okay, in this case are going to be plus or minus c comma 0 because your vertices are on your major axis, and if the major axis is horizontal, that's going to be your x. Okay, the one below here, your foci are going to be on your y-axis because it's vertical, because your a squared is below the y squared in the equation. So your major axis is your vertical y-axis, okay? And that means that your foci are going to be on your y-axis. Okay, so wanted to kind of show you how it all comes together. I actually liked the notes out of the book better, so that's why I wanted to spend a little time on this. Now, let's look at your study guide. Not much new there since we already kind of talked about everything. Again, just want to point out one more time that your vertice is on your major axis. Major axis joins the vertices. Okay? Co-vertices are joined by the minor axis. Okay? And again, let me just say foci are on major axis. A squared is greater than b squared, and c squared equals a squared minus b squared. Those are just some good things to know, I think. Okay? 2 points of information there. Okay, now, graph an equation of an ellipse. Graph the equation 9x squared plus y squared equals 31. Notice on the previous page, I pointed out, let me go back a minute. I pointed out that the formula always has to have a plus and a 1. Okay? Well, we don't have that. Okay? So the first thing we have to do is divide everything here. You notice they're dividing every piece by 36 to get a 1. So you have to first get it in the standard form. So we need a 1 here. We need a plus there for an ellipse. Well, first thing that jumps out at me, this has to be my a squared because it's bigger than this. So that has to be my b squared. Since the a squared is under Since the a squared is under y squared, the y-axis is the major axis. Okay, I didn't draw my asterisk very well, but since a squared is under y squared, y-axis is a major axis. Okay, so, and they go through all of that, yada, yada, yada. So this tells me then that if I take this a step further, okay, this means that b equals square root of 4, or 2, and a equals square root of 36, or 6. Okay, so again, the vertices, these are my vertices on my major axis. These are my co-vertices. So these are co-vertices, these are vertices. Okay, and you'll see how they graphed it there. Now, notice here, they use this formula to find C. So then the foci are at this point. And again, that's on the y-axis because that's our major axis. Okay, so your foci are always on the major axis. Okay, let's do some of these ourselves. Now, I once again added another page so that we could have nice, neat graphs to graph those on so these weren't squished together. So I'm just going to write these 3 problems, 1, 2, and 3 on the next page. Okay, so first problem. Let me just rewrite it. We have x squared over 16 plus y squared over 25 equals 1. Okay, now, first thing that jumps out at me, again, I need to label my parts here. 25 is bigger than 16, so this has to be my a squared, this has to be my b squared. So this means a is 5 and b is 4. Now, since the a squared is under the y squared, that means y-axis is major. Okay, since the bigger number was under the y squared, that means y-axis is major. So that means that my vertices, okay, actually let me do those. My vertices on the y-axis then are going to be 0 plus or minus 5. Okay, my co-vertices are on the x-axis, so that's going to be plus or minus 4, 0. So I have these co-vertices and these vertices. So vertices are 0 plus 5, 1, 2, 3, 4, 5, 0, negative 5, and my co-vertices, again, positive and negative 4, 0. Okay, so I plot my 4 points and then I do my darndest to try to connect them in a smooth way, which you all know me in drawing. That's kind of sad, but it could be worse. Okay, now this one, because the co-vertices 4 and the vertices are 5, okay, there's not a whole lot of difference. So that is similar to a circle. I'm going to give you just a little foreshadowing here. When you get to trig, we're also going to talk about eccentricity, which is a measure of how round an ellipse is. Okay, so anyway, eccentricity is a measure of how round an ellipse is. So it gives you a number between 0 and 1. Anyway, we'll talk about that more in trig, but there's more to know about ellipses. We're just kind of hitting the surface. Now, foci. I believe they also wanted the foci. The directions say graph the equation, identify the vertices, co-vertices, and foci of the ellipse. So we got to find the foci. Remember, for foci, okay, c squared equals a squared minus b squared. So in this case, that is 25 minus 16, which is 9. So that means C equals, well, I should just say 3. Okay, so my foci, remember, are always on the major axis. Okay, so foci are going to be 0 plus or minus 3. So I've got vertices, I've got covertices, I've got foci. Foci are always on the, whoops, not there, the major axis. Okay, so you always look at your vertice coordinates to know where the 0 is. Okay, all right, let's keep moving. So the next problem, let me scroll down. Next problem was x squared over 25 plus y squared over 9 equals 1. Okay, I've got the plus in the middle, I've got the 1 on the outside, so I can go ahead and start identifying. Now, right off the bat, this, because it's the bigger of the two, has to be my a squared. This has to be my b squared. Okay, a squared has to be greater than b squared. So this tells me then that a is 5 and b is going to be 3. So again, since it was under the x squared, this is telling me that x-axis is major. Okay, x-axis is major because the bigger number was underneath it. So this tells me that my vertices are going to be plus or minus 5, comma 0. Those are my vertices. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, those are my vertices. I hope everybody sees that. Okay, covertices. Okay, my covertices, again, my minor axis has to be the y-axis. So that means it's 0 plus or minus 3. That's my covertices. Okay, so up 3, down 3. Okay, let me see if I can draw a nice smooth ellipse through there. That was better. Okay, now focus. Got to find the focus. Remember, for your focus, c squared equals a squared minus b squared. So 25 minus 9 is 16. So this tells me that c equals 4. Okay, so this tells me then that my foci points, and again, your focus is always on your major axis. Okay, focus is always on your major axis. So my foci are going to be plus or minus 4, comma 0. Again, got to be on the x-axis. So here's my foci. So again, imagine that GIF that I showed you earlier. If I thumbtacked a piece of string to those two foci and then drew it tight, and then I could draw my ellipse all the way around it. Okay. I will say and you can probably see this, but the skinnier the ellipse, the closer the foci are to the vertices. Okay. The more circular the ellipse, the closer the foci are to the center. Anyway, for what it's worth. Okay, moving right along. Hope that was okay. Last one here. We've got a little algebra to do first. So we have 4x squared plus 9y squared equals 36. Now, again, basic form of an ellipse, it has to equal 1, right? So first thing I need to do in here is I'm essentially going to divide everything by 36. Okay, so what's that do for my equation? This gives me x squared over 9, 4 goes into 36 9 times, plus y squared over 4, 9 goes into 36 4 times, and 36 divided by 36 is 1. Okay, hope everybody sees that. So I'm dividing all three terms there by the 36. Again, that gives me my basic form. Now, again, the 9 is bigger than the 4, so the 9 has to be my a squared, the 4 has to be my b squared. Okay, that also tells me then that my x is the major axis. Once again, x is the major axis. Okay, so if a squared is 9, a is 3. That means my vertices are going to be plus or minus 3, comma 0. They are on the x-axis. Okay. If my b squared is 4, that means b is 2. My co-vertices have to be on the y-axis. So that's 0 plus or minus 2. Okay. Now again, I've got to find the focus. So, or the foci, whatever. So c squared equals a squared minus b squared. So in this case, that is 9 minus 4. So that is 5. That means that c equals root 5. Okay, if c squared equals 5, then to find just c, we got to take square root of both sides. So that means my foci, again, foci have to be on the major axis. So this is plus or minus root 5, comma 0. I guess I should have been graphing as I found these points. But keep in mind also that square root of 5 is approximately, well, let me write it down here. It's approximately 2.24. So when you go to graph it, that may give you a little better idea of what it's going to look like on the graph. Okay, so first of all, vertices. 3, negative 3, co-vertices, 2, negative 2. Okay, draw my little ellipse here, not too bad. And then my foci are 2.24. So like right in there. Okay, those would be my foci. Okay. All right, I hope that made sense. Let's go to the back page of the study guide. This has taken us a while, I know, but ellipses are brand new. So now write an equation given a vertex and a co-vertex. They give you the vertices. You can tell then whether the vertices are on the x or y axis, and then that gives you your major axis. So you know if you square that coordinate number, whether it's going to go under the x squared or the y squared. Okay. And then of course your co-vertice, you square that coordinate, it's going to go under the other one. Okay. So obviously this vertex here, this is on the y-axis. So that means that a squared is going to equal 25, and it's going to go under the x. Okay, that's what they did here. The co-vertice is negative 4. So that means that b squared equals 16, right? And that's on the y-axis, so that means it's under the y. So it really is that easy, okay? We'll come back to the rug one. Let's look at 4 and 5. It says, write an equation of the ellipse with the given characteristics and center at 0, 0. Okay, vertex and co-vertex. Once again, this vertex is my A. This co-vertex, this is my B. Okay, this A is on the x-axis. So that's going to be my major. Okay, because the vertice is on the x-axis, the vertex. Now, this also tells me then that a squared equals 1. If I square a negative 1, I get 1. B squared, okay, is going to be 9. And since that's on the y-axis, the y is the minor. So if I'm going to write my equation then, okay, this equation is going to be x squared over 1 plus y squared over 9 equals 1. That's my answer. Okay, now you don't necessarily have to write the 1 under the x, but you get, oh, and you know what? I just realized they mislabeled these. Do you all see that? This, your vertex should always be bigger than your co-vertex as far as your A and B numbers go. So this actually should be the other way around. So then, interesting. So that actually means that the y-axis is your major. So they kind of screwed up the labelings. Okay. So let me redo this here. It doesn't change our equation. Okay. But it does, interesting, change how we label it. So they did screw this up. So our vertex here, this would be my A. So A squared would be 9. Okay, this would be the co-vertex. So this is my B, so B squared would be 1. Interesting. I hope you all see that. Your minor axis can't be longer than your major axis. And technically your co-vertices or your co-vertex is on your minor axis. Okay, well, if you're centered at 0, 0, 0, then your minor axis, in this case, if we went with how they labeled them, would be a 6, so your major axis would be a 2. That makes no sense. So anyway, interesting. Okay, number 5. Now, notice they give us the vertex and the focus. They don't give us the co-vertex. So we've got to find it using that c squared equals a squared minus b squared. Okay, so vertex, I'm going to assume this is labeled correctly. Vertex, if this is a, then a squared is 64. Okay, on our focus here, this is c. Notice it's on the same x-axis as the vertex. Okay, so c squared equals 36. Now, we have to find the co-vertex. We have to find the b, or the b squared, so we can write our equation. Okay, so remember, c squared equals a squared minus b squared. So what we have here is 36 equals 64 minus b squared. Okay, well, this is essentially telling us that b squared equals 28. Okay, 36 plus 28 is 64. So this is going to help us write our equation. Okay, are you all with me? So that means, I should have done this in purple here. And we don't really have to find the square root. We don't have to find b. We just need the equation, right? So since this vertex is on the x-axis, x is major. Okay, so if I go to write my equation, it's going to be x squared over 64 plus y squared over 28 equals 1. That would be the equation of our ellipse. The only thing we needed the focus for was to find the b squared so that we could write our equation. Okay, and again, in this case, your major axis is your x. So thankfully the math did work out correctly. Okay, number 6. Now, I want to go back to the example above it of the rug. Number 6 here, area rug. A rug in an elliptical shape is shown at the right. Write an equation of the boundary of the rug and then use the formula for area of an ellipse. This is probably a good formula to keep in your back pocket. Area of an ellipse is pi times a b. Again, a being essentially the length from the center to the vertex, and b being the length from the center to the co-vertex. Okay, so in this case, what they're talking about, from here to here is 5, and from here to here is 3. Okay, if they give you the dimensions of the rug as 10 by 6, then half the 10 is 5, that's your A, half the 6 is 3, that's your B. Okay, and then you can see how they kind of worked that. Now, let's go on down here and do this one. So in example 3, let the horizontal dimension be 12 feet and vertical dimension 8 feet. So let me kind of draw an ellipse here. Okay, now what they have here is that your horizontal dimension, and again, you got to love the dead spots on my board, is 12. Okay, vertical dimensions are 8. So write an equation for the boundary of the rug. First of all, they want the center to be the origin. So from here to here would be 6. So my A is 6. From here to here would be 4. So my B is 4. Your A is 6, and that is also, might I say, your X is your major axis. Okay? Because we're longer on the horizontal than we are on the vertical. So write an equation of the boundary of the rug. So this one's not too bad. We just have x squared over, what's a squared? A squared is going to be 36. And then what's b squared? B squared is going to be 16. So it's x over 36 plus y squared over 16 equals 1. Okay, square the A, square the B. Once you figure out half the horizontal, half the vertical is your A and B. Okay, hope that helps. Now, let's quickly kind of look at the practice A exercises. I know we're kind of going long here, but this is a lot of information. Okay, graph the equation. Identify the vertices, co-vertices, and foci of the ellipse. Okay, first thing, I'm going to kind of blow through this. This has got to be your A squared, okay, because it's bigger. So this has to be your B squared. So that means A is 3, and that means your vertice, again, is going to be on your x-axis, so it's going to be plus or minus 3, comma 0. Okay? Plus 3, minus 3. If b squared is 4, that means b is going to be 2. So your co-vertice is going to be 0 plus or minus 2. Again, it's got to be on the y-axis. So up 2, down 2. Okay? So we have co-vertice. We have vertices. Now your focus, okay? Remember, c squared equals a squared minus b squared, which is 5, okay? So your focus, again, is always on your major axis. So this is plus or minus root 5, comma 0. That's your focus. Okay, and remember we found that root 5 is like 2.24. Okay, so 2 1/4-ish. Okay, so there's your ellipse, roughly speaking. Okay, hope that helps. Now remember, down here, like I don't know, this one just yelled out at me. You're going to have to divide everything by 49. So you're going to end up with x squared over 1 plus y squared over 7. Sorry, not over 7. Your b is going to be 7. Y squared over 49 equals 1. Okay, so then now your a squared is 49. So your a is going to be 7. Your vertice is going to be, 0 plus or minus 7. Remember, because it's under your y squared. Your b is going to be 1. So your co-vertice is going to be plus or minus 1, 0. Okay. I wasn't going to do this one. I was just going to start it and yet here I go. Okay. So we got a really skinny ellipse. Okay. And then your foci. Okay. Remember, c squared equals a squared minus b squared. So 49 minus 1 is 48. So c, square root of 48, 48 is 16 times 3, so 4 root 3. So your foci, remember, are on your major axis. So that would be 0 plus or minus 4 root 3. Okay? Foci, covertice, vertice. And that's, you could do your foci, but it's going to be kind of hard to grasp. They're going to be very, very close to the vertice. Okay. Next part, write an equation of the ellipse with the given characteristics and center. So if your vertex here is 4, 0, this is your A, right? So your A squared is 16. Your vertex is on the x-axis, so your x is major. Okay? And then your co-vertex is 0, 2. This is your B, so that means that B squared equals 4. So if you go to write the equation, you don't need the focus for the equation, and you know that the A squared, because the vertex is on the x-axis, has to be under the x squared. So it's going to be x squared over 16 plus y squared over 4 equals 1. Okay, I hope that helps. Moving right along. Down here, 13 through 15. Now, the equations of a parabola, a circle, and an ellipse are given. Graph the equation. Let me remind you of a couple of things. I'm not going to do these, but let me remind you of a couple of things. Parabolas, actually, let me write this. Whoa, not really sure what that was. Okay, interesting. Okay, sorry. Parabolas have only one squared variable. Okay, so either your x is squared or your y squared, but not both. Okay, circles have the same coefficient in front of x squared and y squared. Circles have the same coefficient in front of x squared and y squared. And ellipses have different coefficients in front of x squared and y squared. So by just looking at these three things, this would have to be the parabola, right? Because there's only one squared term. This would have to be the circle, okay? And my tip to you would be to divide all three terms by 5. Then you can see it a little more clearly, okay? This would then have to be the ellipse because we have different coefficients in front of the x squared and y squared, and my tip to you would be to divide all three terms by 64 to get the 1 on the right hand side. On a circle, you want the coefficients off the x and y term. So you want to divide by the coefficients. On an ellipse, you want the constant to be a 1. So you want to divide every term by the constant. Okay? Hope that's helpful. And then down here, Why does this, okay. An elliptical stained glass window is planned in the construction of a new office building. The window will have a width of 8 feet and a height of 4 feet. Write an equation of the perimeter of the window that can be used on the blueprint. Assume the major axis of the window is horizontal. So they kind of already said that when they gave you the longer horizontal width, but whatever. So this horizontal width, they said, is 8 feet. What does that tell me? That tells me that my A is 4. Okay, then they tell me the height of the window is 4 feet. So what does that tell me? That tells me that my B is 2. Okay, that's all the hints I'm going to give you. You can finish that. Okay, whew, I know this went long. I'm sorry, but this was new information. Hope it was helpful. Again, 8.4 ellipses.